Here we need to calculate the following limit using L'Hopital theorem, which says the following. If I want to compute the limit as x approaches x naught of f of x over g of x, then if I have an indeterminate form, I can calculate the limit as x going to x naught of the derivative of the functions f divided by the derivative of the function g. So let's go to the first one. I have the following limit as x going to pi over 2 cos x plus pi over 2 minus x, and the denominator is pi over 2 minus x. If I substitute here, I have cos pi over 2 plus pi over 2 minus pi over 2 divided by pi over 2 minus pi over 2. What is the numerator? Cos pi over 2 is equal to 0. The numerator is 0 and the denominator is 0, so I have an indeterminate form. So instead I calculate the limit as x goes to pi over 2 of the derivative of the numerator divided by the derivative of the denominator. So the derivative of the numerator is, the derivative of cos is minus sine x minus 1, the derivative in the numerator, and the derivative in the denominator is minus 1. So this can be written as the limit as x goes to pi over 2 sine x plus 1 divided by 1. I can change the signs here. So I can substitute sine pi over 2 plus 1. Sine pi over 2 is equal to 1. So my result is equal to 2 for this limit. B limit as x goes to 0 e to the power of x minus 1 over x. I also have an indeterminate form, 0 divided by 0. So I take the derivative in the numerator over the derivative of the function of the denominator. The derivative of the exponential function is e to the power of x. The derivative of the identity function is 1. So it's e to the power of 0 equals 1. I go to the last limit. It's the limit as x approaches 1 of the function natural logarithm of x plus x minus 1 divided by e to the power of x minus e. So if I make the substitution, I have natural logarithm of 1 plus 1 minus 1 over e to the power of 1 minus e. So I get an indeterminate form. And for this reason, I can use the L'Hopital's rule. The derivative of natural logarithm of x is 1 over x plus 1 over e to the power of x I substitute and I have 1 plus 1 in the numerator, e to the power of 1 in the denominator, so it's 2 over e, the last limit.